Okay, so as promised, we are going to graph the homework problems nice and slow so everybody can see them. The first problem I'm going to graph is number 1 from the homework from 2 nights ago. It's -3 secant 2 theta minus pi plus 2. Okay, now whenever I go to graph secant, I always first kind of make the note that secant is going to act like cosine. Okay, and then I like to take a couple of other notes so I don't have to look back at the problem. I like to write that the amplitude is -3. Okay, 2 pi over k tells me the period. That k value is 2, so my period is pi. Okay, my phase shift is going to be pi over 2. I'm just setting the parentheses equal to 0 to solve for that. And my vertical shift, or h value, is 2. Okay, so now that I have all of that information, I'm going to go to graph it. And I'm going to make sure when I graph it that I leave myself enough space so that I can account for that amplitude and the fact that it's beginning up 2 spaces. Okay, so when I go to label, I'm going to make sure that I label just by single spaces because my amplitude's so large. So I'm up at 2 for my vertical shift. Okay, and then my amplitude is going to put me 3 spaces away from that. So I'm going to go 3 spaces in that direction and 3 spaces in this direction. And then in a different color, just for fun, I'm going to label what those maximum and minimums are. Keep in mind that we're graphing secant, so those don't actually mark my max and min, they actually mark where they're beginning. Okay, the next thing that I'm going to do is label my x-axis. I'm going to go 2, 4, 6, oh, I can't go all the way there. There's 8. 2, 4, 6, and 8. Okay, and my period is pi. That means halfway is pi over 2. Halfway to that is pi over 4. And 3/4 of the way is 3 pi over 4. And then I'm going to do the negative direction for that. I've got negative pi over 4, negative pi over 2, negative 3 pi over 4, and that last one I'm not going to be able to label, but the period shift is positive, so I'm not really concerned about that. Okay, so now we want to start off like this is a cosine. So keep in mind that cosine is supposed to start at its max, but because this cosine has a negative, so because of that negative amplitude, we're going to start negative, but we're also starting negative at a phase shift of pi over 2. So instead of starting on the y-axis at -3, I'm going to start at pi over 2 at -3. Okay, that marks my phase shift. And then from there, I'm going to go to 0, to my max, and then I'm going to go and try and backtrack and do this in the other direction. So the nice thing is that this phase shift actually makes it look like a normal cosine. Okay, and we're going 0 to max, 0 to max, 0 to min, and 0 to max again. That's the pattern. Okay, now keep in mind that this isn't the graph of a cosine, this is the graph of a secant. So what I need to do now is convert this to a secant graph. In order to do that, wherever it's 0, the reciprocal of 0 is undefined because we can't put 0 in the denominator. So wherever it's 0, I'm going to draw vertical lines to mark that it's 0, that it's undefined there. And then what I'm going to do is connect the dots and make my little U-shapes in the opposite direction. Because whenever I take the reciprocal of a half, I'm going to get 2. Whenever I take the reciprocal of root 2 over 2, I'm going to get root 2. These numbers are all larger. That's why they're outside that minimum maximum barrier that you would normally see with a cosine graph. Okay, so there you have it. That's y equals -3 secant 2 theta minus pi plus 2. Okay, next up we are going to graph y equals 4/3 cosecant of theta over 4 plus pi over 2 minus 3. Okay, and once again, I'm going to make myself those little side notes. This is going to act like sine. The amplitude is 4/3. My 2 pi over k puts me at 8 pi for a period. And then my phase shift, I'm going to solve this out just because it's a little bit more complicated. I'm going to do theta over 4 equals negative pi over 2, which ends up translating to a phase shift of negative 2 pi. Okay, so that one's a negative phase shift. And then my vertical shift, we're going to be down at negative 3 for this one. Okay, so now when I draw this, I want to account for that vertical shift. So when I draw this, I am going to make sure that my x-axis is up here a little to account for the fact that there's a pretty big vertical shift. I'm going to label 1, 2, 3, 4, 5. Okay, and then I'm going to do my horizontal marker where my vertical shift is. And then in a different color, I'm going to go up 1 1/3 and down 1 1/3. Okay, and this part, don't get too obsessed about it. We're approximating. It's a fraction. That's all we can do. There's no way we would be able to graph that accurately. So the next thing that I'm going to do is start labeling my x-axis. So I have 2, 4, 6, 8 in one direction. In the other direction, I have 2, 4, 6, and for some reason, again, I'm a little off-center here. This shift is negative 2 pi, but the period is 8 pi. So in the positive direction, I'm going to label 8 pi. There's 6 pi, 4 pi, and 2 pi. And then in the negative direction, I have negative 2 pi, negative 4 pi, negative 6 pi, and I didn't have room for that 8 pi, but that's all right. We'll just keep going. So now my phase shift is negative 2 pi. My sine is supposed to start at 0. So instead of starting at 0, negative 3, I'm going to start left 2 pi from there. So I'm starting there. Okay, and then sine goes from 0 to max. So I'm going to go from 0 to max, 0 to min, 0 to max. Okay, and then I'm going to do that again in the other direction, minimum, 0, and then back up to max, but we don't see that. And now once again, because I'm graphing the cosecant and not the actual sine, wherever I hit 0 is where it's going to be undefined. Okay, keep in mind that this is actually at 0, it's just been shifted down negative 3 spaces. So this would technically be undefined minus 3, which is still undefined, no matter how you slice it. Okay, and now what I'm going to do is connect the dots and create my secant graph. So here we are, here we are, here we are, here we are, and here we are. Okay, so shifting this by negative 2 pi actually makes it look like a cosine graph. Well, a secant graph instead of a cosecant graph because of the phase shift. Okay, so next up we're going to graph number 3. Number 3 is y equals negative 3 tangent of theta minus 1. Okay, and this one's much simpler because there aren't any phase shifts or anything like that. I am still going to indicate that amplitude is negative 3. Technically, for tangent, it's pi over k to find the period, but again, we're going to pretend that it's 2 pi over k so that we can graph a couple in each direction. There is no period change here, and we have a horizontal shift of negative 1. So I'm going to go ahead and graph that. This one's going to be much quicker. I'm going to graph that. I'm going to go up a little so that I have room. And I'm going to label negative 1, and then going 1, 2, 3 spaces in that direction, and then 1, 2, 3 spaces in the vertical, and then 2, 4, 6, I don't have room, 2, 4, 6, 8. Okay, so then again, I am going to label my period. My period is going to go to 2 pi even though we're talking about a period of pi. Okay, but it's just easier this way. I've got pi over 2, negative pi over 2, negative pi, negative 3 pi over 2. Okay, and then I can indicate where my maximum and my minimum are, but I've actually just labeled out to where those points are, so it should be easy for me to do this part. What I am going to do is indicate where it's undefined. This is really easy because there isn't a number in front of the tangent. The tangent's undefined at pi over 2 because you have the sine of 1 over the cosine of 0, so you have 1 over 0. Okay, and then again at 3 pi over 2, and I'm just going to do that in both directions. Okay, the only thing that's even remotely tricky about this one is that we have that negative amplitude. So now I'm supposed to, the tangent of 0 is 0. When I get to the tangent of pi over 4, which is 1, I'm actually multiplying that by negative 3. So I have negative 3 minus 1. Okay, the negative 3 minus 1 brings me down to negative 4. Oh, whoops, that is actually supposed to be here at negative 1 because of that vertical shift. So that actually brings me down to negative 4. So at pi over 4, I'm at 1, 2, 3, 4. So I actually have, if you think about it, I actually have gone negative 3 spaces. That is my amplitude. Okay, but if you look, this looks more like a cotangent than it does a tangent because of that shifting. So here we are, and we're just going to mimic it. As soon as you know what one period looks like with the tangent, you can just mimic it. You don't have to worry about that a bunch of times, but plugging in one point usually helps for you to get your bearings and figure out where your points are going to be, and then you can just mimic. Okay, so that's what she's going to look like. And do we have room for one more? Not really. So here is negative 3 tangent theta minus 1. Okay, next up, we're going to graph y equals 2 cotangent of 2 theta. Okay, now again, it's supposed to be pi over k, but we're going to call it 2 pi over k just for convenience so that I can graph multiple periods at the same time because it's funny looking, let's be honest. So 2 pi over k equals 2 pi over 2, so we're going to label a distance of pi. So now I am going to, there's no shifting, so I don't have to worry about that. I'm going to draw my vertical axis, and I'm going to start labeling. I'm going to label 2 up and 2 down from the center, and then I'm going to go 2, 4, 6, 8, and 2, 4, 6, and I can't fit it for some reason. And now I'm going to start labeling. I know that because my period is now pi, it's now pi, that this is pi over 2. Okay, this is pi over 4, and this is 3 pi over 4. Okay, and then again in the other direction, I've got negative pi over 4, negative pi over 2, negative 3 pi over 4, and we don't quite have the room for this, but that's okay. All right, so now the cotangent is undefined whenever the tangent is 0, because the cotangent and the tangent are reciprocals of each other. So the tangent is 0 at 0. Okay, so this is going to be the first moment where I have an asymptote. Okay, it's going to be right at that 0 marker. Okay, now I've got to figure out where the next moment is. The next time that the tangent is 0 is at pi. Okay, but this 2 value in here makes this a different conversation. I've got to figure out when 2 theta equals pi. 2 theta equals pi when theta is pi over 2. So here's the next spot where the cotangent is going to be undefined. Okay, so 2 theta, 2 times pi over 2 is going to give me pi. And that means that I'm taking the cotangent of pi, which means I'm undefined. Okay, now again, I want to look at this. Okay, I want to figure out at pi over 4, the cotangent of pi over 4 is actually going to be the cotangent of pi over 2 because we're plugging in double that. Okay, so the cotangent of pi over 2, tangent's undefined there, cotangent is 0. Okay, now the next thing that we need to figure out is pi over 8. When I plug in pi over 8, I've got 2 times pi over 8, so it's pi over 4. So now I'm looking at the cotangent of pi over 4, which is in the first quadrant. It is 1, but I'm doubling it, so it's 2, okay? And there's your distance of 2 from the center, okay? And that means that this guy over here is going to be -1. I could prove it to you if you wanted me to, but for lack of time, let's just assume that that is the pattern. And then I am just going to mimic it. I have 1 period. Now I'm going to mimic it. Here we are. And I do have room for 1 more. So now I'm just going to connect the dots, and now I have 2 cotangent of 2 theta. And there you go. So that was number 4. Okay, next up, we are on number 5, which is y equals 5 secant of theta over 3 minus pi minus 2. Sorry that pi is a little messy. I'm actually going to change this to a smaller grid. You might not be able to see it as well, but it'll allow me to get those 5 spaces in. Okay, so again, I'm going to indicate to myself that the secant is going to act like cosine. Okay, I have an amplitude of 5 and a vertical shift of -2. Those are the first couple of things that we do. And then when I do 2 pi over k, I have 2 pi over a third, which ends up being 6 pi. And when I solve, setting theta over 3 minus pi equal to 0, I get that my phase shift is 3 pi. Okay, so no big deal. It probably looked harder than it actually translates to. So here what I'm going to do is indicate where that vertical line is. I know I'm going down 2 spaces, but I also have to go out 5. So I am going to kind of draw that coordinate plane right in the middle. Okay, and now I'm going to indicate 2, 4, 6, 8. I could go further, but I won't. 2, 4, 6, 8. And then I'm at 1, 2. Here is my marker. Here is my center. Okay, a little sloppy of a dotted line, but we'll ignore it. And then I need to go up 5. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. Okay, so here are my maximum and my minimum. Keep in mind that we do have to draw those little U's, so we do need the space, even though right now it seems a little crammed. Okay, again, sloppy dotted lines, but that's all right. So now I do have my maximum and my minimum, and now I want to start labeling what my x-axis is. So my x-axis, 6 pi, is my period. Halfway is going to be 3 pi. Halfway for that is 3 pi over 2. And then I believe the next one is 9 pi over 2. I think that's right. 3 pi would be 6 pi over 2. Yeah, it is. It's 9 pi over 2. We're going to say yes. Okay, and then in the other direction, I've got -3 pi over 2, -3 pi, -9 pi over 2, and then -6 pi. Okay, and now I'm going to start graphing this like it's cosine and then transition to a secant. Okay, so a cosine's supposed to start at its max, so here we go. 0, min, 0, max. And then in the other direction, 0, min, 0, max. And now what I'm going to do, because this is secant and not a cosine, I'm going to draw vertical dotted lines every time this hits 0, because secant and cosine are reciprocals of each other. And every time that the cosine is 0, when I take its reciprocal, I get a secant that is undefined. So here we have a bunch of asymptotes. Okay, and now I'm going to graph the real graph. Okay, the real graph is just a series of U-shapes on the outskirts of what the cosine function should normally look like. So here I have all of those U-shapes, and I have another one over here. Okay, so that is 5 secant of theta over 3 minus pi minus 2. Okay, next up, we are graphing y equals 3/2 tangent of theta over 2. Okay, and I am going to change this back into larger squares so that we can see this. Okay, so once again, I am going to label my x and y axis. This doesn't have a shift at all, so we're just worried about the amplitude and the change in the period, just so we are aware 2 pi over k, when it's theta over 2, ends up becoming 4 pi. Okay, so that's how much we're going to label. We're going to label 2, 4, 6, 8 in each direction. 2, 4, 6, 8. And then I've got negative 4 pi, and this is nice because it just counts by ones. Negative 3 pi, negative 2 pi, negative pi. And then we go 1 pi, 2 pi, 3 pi, 4 pi. Okay, and then the next thing that we have to do is label what 1.5 is. Just to stretch this out so that it's not so crammed by my markers, I'm going to call that 1, 2, and 1, 2, just so we can see this a little better. So then my 1.5 is going to be at that halfway point in between. Now the next thing that I'm going to do is try and figure out when is this undefined. Okay, and it's undefined, the tangent is undefined when I'm taking the tangent of pi over 2. Okay, in order to be pi over 2 for this one, I would have to plug in pi for theta. So when we're at pi, okay, when I plug it in to my equation, I'm actually at pi over 2. When we're at 3 pi, I'm actually at pi over 2. When we're at negative pi, I'm actually at negative pi over 2. And when I'm at negative 3 pi, I'm actually at negative 3 pi over 2. Okay, now I'm going to go to graph. Okay, the tangent of 0 is still 0. Now when I do the tangent of pi over 2, which is that halfway point between 0 and pi, I'm actually doing the tangent of pi over 4, which is positive 1, times 3/2, so I'm going to go up 1.5. Okay, if I'm going up 1.5 on the right-hand side, that means I'm going down 1.5 on the left-hand side. So here's my pattern, up 1.5, down 1.5. Here I am again, up 1.5, down 1.5. Okay, and then in the negative direction, up 1.5, down 1.5, 0, up 1.5, down 1.5. And now I can connect the dots and I have the graph of my tangent. Here I am at 3/2 theta over 2. Okay, so it really is the exact same graph. The only difference is how we labeled the x-axis. Next up is a tangent with the phase shift. I have y equals 2 tangent of theta minus pi over 2 plus 1. Okay, so this tangent does have a phase shift. It's no big deal. My 2 pi over k is still going to be 2 pi because that k value is 1. So we're going to pretend that the period is 2 pi. I have an amplitude of 2, a vertical shift of 1. Okay, and then my phase shift is going to be pi over 2. So now I'm going to go to label. When I label, I'm going to make sure that I leave myself enough room for my vertical and horizontal shift. Okay, I am going to go out 2, 4, 6, 8 spaces in each direction. 2, 4, 6, 8 spaces. And I'm going to label from negative 2 pi to positive 2 pi. So I have negative 2 pi, negative 3 pi over 2, negative pi over 2, my quadrantal angle, so nothing new there. Then I have pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so now what I'm going to do is think about when is the tangent undefined. Okay, because now my vertical asymptotes have changed because of the phase shift. Oh, we can label 1, 2 spaces, 1, 2 spaces. That way we have that for a marker. Okay, so I do have a phase shift. My tangent is undefined when the tangent, when I take the tangent of pi over 2. So I need to figure out where do I have to be in order for the tangent to be positive pi over 2. And that'll help me mark up where those asymptotes are. Okay, so if I plug in pi pi minus pi over 2 is going to give me pi over 2. When I take that tangent, it's going to be undefined. Okay, when I do 2 pi minus pi over 2, think about the quadrants there. I'm doing 2 pi minus a quarter, so that's going to put me at 3 pi over 2, and that's why it's undefined there. That means that at 0, I'm at negative pi over 2. That's coterminal to 3 pi over 2. At negative pi, okay, I'm at negative 3 pi over 2, which gives me positive pi over 2, actually, coterminal. Think about it. You'll get it. So then at pi over 2, when I plug in pi over 2 minus pi over 2 is 0. I'm actually taking the tangent of 0 here, so I actually am at 0. Actually, I'm not at 0. I'm actually at positive 1 because there is a vertical shift that I forgot to account for. Look at that. Okay, so I am actually taking the tangent of 0, multiplying that by 2, and then adding 1 to it. So I end up being here at positive 1. Okay, now when I do the tangent of pi over 4, pi over 4 minus pi over 2, yeah, that's going to put me at pi over 4 minus pi over 2 is going to put me at negative pi over 4. At negative pi over 4, I'm in the fourth quadrant. My tangent is negative, so I have negative 1 times 2, which is negative 2, plus 1, so it's negative 1. Okay, so that is actually shifted my tangent, and I'm at my negative 1. I'm at a distance of 2 from my vertical shift. Okay. Here's another distance of 2 from my vertical shift, okay? And now that I know the pattern, and I know that that is a distance of 2, I just need to figure out, on which side is the negative direction and on which side is the positive direction, and then I can just continue the pattern. Okay, so now what I'm going to do is just connect the dots, and I have my tangent with my phase shift. Okay, it does really help just for one period to plug in an angle and see whereabouts is that graph supposed to be. It's very helpful. I recommend it. Okay, next up, last up, we are graphing y equals 4 cosecant of 4 theta minus pi plus 2. Okay, and then I'm going to just write myself a little note that this is going to act like sine. My amplitude is 4. My vertical shift is 2. 2 pi over k actually puts me at a period of pi over 2, which is probably going to be annoying. And then my phase shift is pi over 4. Okay, so now I'm going to go to graph, and I've got a vertical shift that I need to worry about, and an amplitude that's pretty big. So when I label this, I'm going to be very careful. I'm going to make sure I go 2, 4, 6, 8 in each direction for those guys like normal. Okay, but now I want to do a vertical shift of 2. So this is my marker. Okay, and then I'm going to go up 1, 2, 3, 4, and then down 1, 2, 3, 4. Okay, and those are my maximum and minimum. We can still label them as maximum and minimum. It'll help us see where we're supposed to draw those U's so we can draw them quick. Okay, and sloppy dotted line. Okay, so now the next thing that I'm going to do is label that x-axis. Okay, that way I can clearly tell where my phase shift is. We're talking about a period of pi over 2. Okay, halfway would be pi over 4. Halfway from that would be pi over 8. Okay, and then I'm actually adding pi over 8 and 2 pi over 8 to get 3 pi over 8. No big deal. That third value is always a little awkward. I've got negative pi over 2, negative 3 pi over 8, negative pi over 4, and negative pi over 8. Okay, so now what I'm going to do is indicate where those sine values should be, and then from there I'm going to build out what my cosecant should look like. So 0 to max, 0 to min, 0. Oh, I forgot about the phase shift. Let's back that up. Phase shift. Okay, I'm supposed to begin at 0, but I'm shifting over to pi over 4. Okay, so I'm actually beginning there. there. I'm supposed to go 0 to max, like we just did 2 seconds ago when I forgot about the phase shift. Okay, so I'm going to go 0 to max here, and then back to 0, and then I'm going to continue the pattern in the opposite direction, back down to the minimum, to 0, to the maximum, to 0, to the minimum, to 0. Just creating that wave-like pattern. And then what I need to do is take into account that whenever the sign is 0, its reciprocal is undefined. So whenever the sign is 0, its reciprocal is undefined. And here I have my asymptotes. Okay, so now then, in between these asymptotes, I can draw my cute little U-shapes. We're not very accurate when we draw these. We're drawing sketches, just like we did with rational functions when there were crazy asymptotes in those. And here I have 4 cosecant 4 theta minus pi plus 2.